So, hello brothers and sisters, good morning to all. Today's session is continuation of halogen family. Last class we are discussed about chemical properties of chlorine and uses. Now we are discussed about hormones of halogen. That is HX. Here, all the halogen combine with the hydrogen and form HX. HX nothing but covalent hydride. That is HF, HCl, HBr and HI. This name hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide. Another name called as halogen acid or hydroacids. How to prepare all that compounds you have to discuss later. First preparation HF. Point number 1, by heating of fused potassium hydrogen fluoride, it is a KHF2 heated to formation of HF and KF. Balance equation, how many potassium? 1 potassium, how many hydrogen? 1 hydrogen, how many fluorine? This is 2 fluorine. This formed as a anhydrous HF. This anhydrous HF always stored in well cooled silver, gold, platinum vessels. Another method, by heating of calcium fluoride. That is a calcium fluoride heated with a concentrated sulfuric acid about 90% and the formation of HF calcium sulfate. Balance equation, how many fluorine? 2, here 2 hydrogen, so 2 times. This name aqueous solution of hydrogen fluoride. HF attack the class and etching on the class. Here HF diluted, that is a dilute HF is kept on gutta percha vessels. This one nothing but polymerization of isobutylene. Concentrated HF is kept on wax bottles. These are the preparation of hydrogen fluoride. Another one, preparation of hydrogen chloride. Hydrogen chloride can be prepared by the salt cake method. Here, that is a concentrated sulfuric acid react with the rock salt, that is a sodium chloride. Formation of HCl and sodium sulfate. Balance equation, Common hydrogen, 2 hydrogen, here 1 hydrogen 2 times. Common chlorine, here 2 chlorine, here 1 is 2 times. 2 sodium, 1 sulfate. Here, heat will be absorbed. This reaction known as endothermic reaction. This reaction followed by, there are 2 different temperatures. First, that is a solid sodium chloride react with the sulfuric acid, maintain at a temperature 420 Kelvin. Here, hydrogen react with the chlorine to formation of HCl plus sodium bisulfate. Balance equation: sodium, here 1 sodium, 1 chlorine, chlorine, 2 hydrogen, here 2 hydrogen. Here HCl is coated with insoluble sodium bisulfate. This one prevent the further reaction. This method known as salt cake method. In the salt cake method, the mixture of HCl and sodium bisulfate, that is a sodium bisulfate, react with the sodium chloride at high temperature 823 Kelvin, formation of HCl plus sodium sulfate. This one formed as a byproduct. Byproduct used for making the paper. This method known as a craft method. One more question may be asked. In the craft method, what temperature used? 823 Kelvin temperature used is a formation of HCl and sodium sulfate. HBr and HI cannot be prepared by this method. Why? Because HBr and HI, strong reducing agent, reduce the sulfuric acid converted into SO2. For example, that is NaI react with the H2SO4, formation of HI plus sodium sulfate. Here 2 sodium is a 2 sodium, 2 iodine, 2 hydrogen. This HI acts as a powerful reducing agent, so reduce the sulfuric acid converted into SO2 plus water and liberation of iodine. Balance equation: 1 iodine, here 2 iodine is a 2 times. Common hydrogen, here 2, 4 hydrogen 2 times. Common sulfur, 1 sulfur. Common oxygen, 4 oxygen, here 2, here. Here iodine is a -1 oxygen state. This iodine is a 0. Oxidation number increases. So this acts as an oxidizing agent. This compound undergo reducing agent. This reducing agent, this acts as an oxidizing agent. In the same reaction, reducing agent and oxidizing agent takes place. This reaction known as a redox reaction. So HBr and HI cannot be prepared by this method because of HBr and HI decompose sulfuric acid converted into SO2. Another method, from 1,2 trichloroethane. Here CH2 Cl CH HCl. Common name ethylene chloride. IPAC name 1,2 trichloroethane. This undergo heated nothing but dehydrohalogenation. What is a dehydrohalogenation? Removal of chlorine and hydrogen. Formation of HCl plus CH2 double bond CHCl. This name vinyl chloride. HCl formed as a impure as a byproduct. This is another preparation of HCl. Next, preparation of HBr. By direct combination. Hydrogen react with bromine in the presence of PT. This takes place in PT retard. Formation of HBr. Balance equation 2 hydrogen 2 Br is 2 times. Another method, by heating bromide on orthophosphoric acid. Orthophosphoric acid formula H3PO4. This react with the sodium bromide H3PO4 undergo heated, that is a concentrated orthophosphoric acid. Hydrogen react with Br to form HBr plus sodium phosphate. Balance equation, common Br, 1 Br, here 1 Br, common sodium, 3 sodium, so 3 times, 3 Br, 3 hydrogen, 3 times. Sodium bromide react with concentrated orthophosphoric acid to formation of HBr and sodium phosphate. Here sodium valency plus 1, phosphate valency minus 3, so cross multiplication. Next, preparation of HI by direct combination. That is a hydrogen react with iodine in the presence of PT, maintain the temperature 450 degrees Celsius to formation of HI. This method prepared by the HI, 2 hydrogen here 2 iodine is a 2 times. Another method, by heating iodide with concentrated orthophosphoric acid. That is a sodium iodide react with the H3PO4 formation of HI and Na3PO4. So 3 sodium, so 3 times. 3 iodine is 3 times. This method common for all means HCl, HBr, HI. Next, hydrolysis. Hydrolysis of PI3, that is a phosphorus triiodide. Hydrolysis means to formation of HI and phosphorus acid. Balance equation, common iodide 3, so 3 times. Common hydrogen here 3 is 3 times. 3 oxygen, 3 hydrogen, 1 phosphorus. This method common for all HCl, HBr and HI. Next, properties. First property, physical property. Except HF, other hydrogen halides are gases. HF is what liquid, it forms the intermolecular hydrogen bonding. The bond angle is 140 degrees Celsius. It forms the intermolecular hydrogen bonding. Except HF, remaining all hydrogen halides are gases. HF, it forms the intermolecular hydrogen bonding. Any compound, it forms the intermolecular hydrogen bonding, maybe high boiling point, but HF is low boiling, about 293 Kelvin. HF is a weak acid. Because of fluorine more electronegative is bonded with the hydrogen. This bond, strong bond, cannot easily release the hydrogen. So HF is what? Weak acid. Remaining all halogen acid is a stronger acid. Order of acid strength. HI greater than HBr greater than HCl greater than HF. These are order of acid strength as well as reducing property. This HF is a weakest acid, extremely stable, cannot oxidize by the oxidizing agent. All hydrogen halides are heavier than air and liquefied to the colorless liquid. HF attacks the glass. That is etching on glass. These are the physical properties of hydrogen halide. Another one is a chemical properties. First, point number 1, acidic nature. Point number 2, reaction with the salt. Point number 3, reaction with the ammonia. Point number 4, reaction with halogen. Next point, precipitation reaction. Next point, reducing nature. Next one, reaction with aquaresia. These are the chemical property. Among the property, precipitation reaction is very important. This is a precipitate compounds, insoluble, concentrated nitric acid. We discuss about one by one. First chemical property, acidic nature. Here, metals, oxides, carbonate, bicarbonate, hydroxides. All are reactive with HX. HX nothing but HCl, HBr, HI. HF is a explosive compounds and form salts. First one, metals. Metals react with HCl or HBr or HI and form salt plus hydrogen gas. Hydrogen gas formed as a pop sound. For example, any metal, magnesium or zinc. Mg react with HCl, that is a concentrated HCl. Here, magnesium valency 2 because of beryllium family. What are the beryllium family? Beryllium, magnesium, calcium, strontium, barium, radium, all are valency 2. So, here magnesium valency 2 react with the halogen to formation of MgCl2 and a liberation of hydrogen gas. So, metal, whatever may be any metals react with the HCl, that is a concentrated HCl to formation of salt. This name magnesium chloride and liberation of hydrogen. Balance equation, common chlorine, 2 chlorine is a 2 times. Is a 2 hydrogen. This react with the metals, oxide, carbonate. Another one, carbonate. Carbonates react with the HX, formation of salt plus carbon dioxide plus water. These are the formula. Carbonate, for example, calcium carbonate react with the HCl. Salt, calcium react with the chlorine to formation of calcium chloride. Next, carbonate produce carbon dioxide, CO2. Hydrogen react with oxygen to form H2O. These are the method. Balance equation, calcium, 1 calcium, 1 calcium. Common chlorine, 2 chlorine is 2 times. Common hydrogen, 2 hydrogen. Common carbon, 1 carbon. Common oxygen, 3 oxygen. Here 2, here 1, 3 oxygen. This property known as acidic nature of HX, maybe HCl, HBr and HI. Next, reaction with the salts. Here, sulfides, phosphides, sulfite, nitrite, thiosulfate, all react with the HX, that is HCl, HBr and HI. Produce gases. These are the methods. First one is a sulfide. Any one of the compound? Sodium sulfide. Sodium valency 1, sulfide valency 2. So cross multiplication. React with the HCl. Formation sodium react with the chlorine to formation of NaCl plus H2S as a gas. Balance equation, 2 sodium is here 1 2 times. Common chlorine, 2 hydrogen 2 times. Common sulfur, 1 sulfur. Another one is a phosphide. Calcium valency 2, phosphorus valency 3, so cross multiplication. React with the HCl. And the formation of calcium chloride plus phosphine as a gas. Common calcium, 3 calcium, so 3 times. Common phosphorus, 2 phosphorus is 2 times. Common chlorine, 6 times. Common hydrogen, 6 hydrogen, 2 into 3, 6 hydrogen. So this one reaction with the salt. What are the salt? Sulfide salt, phosphide salt, sulfite, nitrite, thiosulfate, all are react with the either is HCl, HBr, HI and form the gaseous molecule. Here H2 as a gas, phosphine as a gas. Another chemical properties, reaction with the ammonia. Here, ammonia react with HX, HCl, HBr is a HI. Formation of white fumes. For example, HCl react with ammonia to formation of NH4Cl, that is a white fumes. White fumes formed as a ammonium chloride. Next, reaction with halogen. For example, fluorine is a halogen, react with any one, either HCl, HBr, HI, to formation of HF and liberation of chlorine. Chlorine, how many chlorine? 2 fluorine, 1 is a 2 times, 2 hydrogen, 2 chlorine. Here, fluorine is more active, more electronegative, more reactive. More reactive element displaces the less reactive element from the HCl. This reaction known as a displacement reaction. Another one, precipitation reaction. That is AgNO3 react with HX, formation of AgX as a precipitate plus nitric acid. These are the precipitation reaction. This precipitate, that is a precipitate, does not react with concentrated nitric acid, so precipitate will be formed. For example, AgNO3 react with the HCl, formation of AgCl plus HNO3. Here AgCl formed as a white precipitate. This white precipitate insoluble in nitric acid and soluble in ammonium hydroxide. Formation of silver chloride as a what precipitate? White precipitate. Next, silver nitrate react with the HBr to formation of AgBr as a pale yellow precipitate plus HNO3. This one used as a photography. This component insoluble in concentrated nitric acid and sparingly soluble in ammonium hydroxide. Next, silver nitrate react with HI, formation of AgI as a yellow precipitate plus nitric acid. This one used as a photography. This component insoluble in concentrated nitric acid and ammonium hydroxide. This reaction known as precipitation reaction. Another one more reaction, reaction with aquaresia. aqua ratio? Aqua ratio nothing but mixture of concentrated hydrochloric acid and concentrated nitric acid. Both are concentrated. Ratio is 3:1. This react with gold and platinum to formation of gold chloride or platinum chloride. For example, AU react with HCl, HNO3. Formation of AuCl3 plus NOCl plus H2. These are the product. Balance equation. Common chlorine is 3, here 1, 4 chlorine, here 4 not at all possible because the ratio 3:1. So this is 3 times, this is 9 times. Now common chlorine, here is what? Common nitrogen, 3 nitrogen. Common chlorine, here 9 chlorine, 3 over, remaining 6 is 2 times. Common AU is 2 times. Common hydrogen 9 plus 3, 12. Here is 6. 6 into 2, 12. Common oxygen, here 9 oxygen. Here 6 plus 3, 9 oxygen. These are the methods for preparation of aqua ratio compounds by using the AuCl3. Yes, water may be any metal like Au or PT react with the aqua ratio. Ratio is 3:1 and formation of AuCl3 and NOCl and is a water. Next, uses. First, uses of HF. HF used as attack class. Next, HF used as a manufacturer of fluorine. Another one, NAF, that is used as a insecticide. These are the uses for HF. Another one, uses for HCl. HCl used for manufacture of chlorine, metal chlorides, that is ammonium chloride and glucose. Glucose formula C6H12O6. Another point, preparation of glue from bone and tissue cells. Next one, it is used for purification of bone block. Finally, it is used for preparation of aqua ratio. You know that aqua ratio nothing but mixture of concentrated hydrochloric acid and concentrated nitric acid. The ratio is 3:1. React with the AU to formation of AuCl3. Aqua ratio is special character, react with the gold and platinum. These are the uses for HCl. Another one, uses for HBr. First one, for making NABr and KBr. These are used for sedatives. Another one, AGB are used as a photography. These are the uses for HBr. Uses of HI. HI used for strong reducing agent. It is used in preparation of AGI, that one used for photography. These are the uses for hydrogen halide. First one HCl, HF, HBr and HI. Let us recap the preparation of compounds of halogen. First, how to prepare halogen acid. All the halogen combine with the hydrogen and form the covalent hydride. Here, activity of hydrogen decreases from fluorine to iodine because of fluorine is a more electronegative elements. Another one more property, that is what, reducing nature. Here, that is a bond dissociation energy inversely proposed to the reducing nature. Here, bond dissociation energy, there is a HF, HCl, HBr and HI. Fluorine is a more electronegative, strongly bonded with hydrogen. This one is a high bond dissociation energy. Bond dissociation energy inversely proposed the reducing nature. That is a HI greater than, HBr greater than, HCl greater than HF. This type of question may be asked the 1 mark. Which one is a powerful reducing agent? Because of hydrogen iodide, the bond is a weak bond. This is a stronger acid. This one reduce the sulfuric acid converted into SO2. For example, HI react with H2SO4 and formation of SO2, water and liberation of iodine. Common iodine, 2 iodine is a 2 times. Common hydrogen, 2 hydrogen, here 2 is a 2 hydrogen. Common oxygen, here 2, here 4 oxygen. So, among all the hydrogen halides are, HI is the best reducing agent. Reduce the sulfuric acid converted into SO2. Here, sulfur exhibit plus 6 oxygen state, this is a plus 4 oxygen state. Oxidation state is a decreases, reduction. This acts as a oxidizing agent. Here iodide -1, here 0. Oxidation state is a increases. Increase mean oxidation. This acts as a reducing agent. Here hydrogen halides is a HI is a very important property. This acts as a powerful reducing agent. These are the general character. Another one is a preparation of HF by using the potassium hydrogen fluoride and calcium fluoride. Another one, preparation of HCl by the salt cake method and craft process by using the different temperature 420 Kelvin and 823 or 20 Kelvin. This reaction known as what? Endothermic reaction. Another one is from 1,2 dichloroethane. This will give the vinyl chloride and HCl. HCl formed as a impure as a byproduct. Next, preparation of HBr and HI, direct combination and heated with bromide or iodide on concentrated orthophosphoric acid. Next, physical property. Here important physical properties are HF is a liquid, it forms the intermolecular hydrogen bonding, remaining all are gaseous molecule. HF is a weak acid, is a extremely stable it cannot oxidize by the oxidizing agent. Another one is a chemical property, acidic nature, reaction with the salt. Another one a reaction with ammonia, reaction with the halogen. Another precipitation reaction, reducing property. Another one is a reaction with the aqua ratio. Aqua ratio, another name, royal water. This is a combustion of mixture of HCl and HNO3 ratio about 3:1. Another one is the uses of HF, HBr, HCl and HF. Here you have to practice the equation regularly and get highest mark. Good luck.